Okay class, so today we're going to start a new topic on mass weight density. This topic is not something actually new to you, but you have actually learned this in Sec 2. So this is actually just a refresher. So let's look at the content of the topic. So first of all, we will talk about the mass and the weight, followed by inertia, and then lastly, density. So first of all, for mass and weight, what we're going to learn? We are going to learn about what's the definition for mass, what is gravitational field, what is gravitational field strength, and we're going to differentiate between mass and weight. And lastly, we're going to recall and apply the formula weight equal to mass times gravitational field strength to solve problems. So let's recall what is weight. So you will be very familiar with this diagram probably. Some of you might have heard of stories of how Isaac Newton came to realize that there is a gravitational field around us. It is when he was lying under a tree and an apple fell from the tree and hit his head. So in that incident, he realized that there must be something pulling the apple towards him, and this made him discover the idea of the gravitational pull. So weight is a gravitational force exerted by Earth on an object. And weight is a vector. The reason why weight is a vector is because in the case of this diagram, the weight is always acting down towards the person. Alright? So that's why it's a vector. So what is mass and how is it different from weight? And what is the gravitational field and the gravitational field strength? So these are the ideas that we're going to explore in the next few slides. So what is mass? Mass is the amount of matter in a body. For example, if let's say I have an object that has 1,000 atoms and another object with 20,000 atoms. Of course, the second object will have more mass if the atoms are of the same size, right? So it is the measure of how many of this kind of matter is accumulated in the body. Of course, if you have more matter, you will have more mass. Alright, and the SI unit for mass is in kilogram. So if that's mass, what is weight? Weight is actually of an object is actually the gravitational force of gravity that is acting on the object. Alright, and the SI unit for weight is in Newton. Okay, so the difference between mass and weight is that one is a measure of the amount of matter, while the other one is a gravitational force of gravity acting on the body, and their units are different. Okay, so now that we have learned about mass and weight, let's look at something that is related more towards weight. What is a gravitational field? A gravitational field is a region in which a mass experiences a force due to the gravitational attraction. Now let's say we are standing on any parts of the globe, whether we are standing at this position, right, or maybe this position, you realize that the weight or the gravitational pull that you experience is always downwards towards the center. Okay, towards the center. And if you draw a line down, you realize that all the lines, regardless of where you are coming from, will go towards the center of the Earth. Sorry, my lines are not very straight, but you got my point. It will go to the center of the Earth. Alright, so that means that the gravitational field strength or the gravitational field is always acting towards the same point. Alright, when a mass is placed in a gravitational field, it experiences a gravitational force. The gravitational force is also known as the weight, and in this case, the Earth's gravitational force acts towards the center of the Earth. Alright, okay. So what can we know about the gravitational field of Earth? The field is the strongest when it is near the surface of the Earth, and it gets weaker further away. And in other words, if let's say the gravitational force experienced by an object due to the Earth's gravitational field gets stronger as the object moves closer to the Earth. So imagine you have an object that is maybe a few hundred kilometers away from the Earth. Let's say here it has a weight of 50 Newton. So this is the gravitational pull that the Earth has on the object. If this object now moves very close to the Earth, that means it has moved all the way here. Now the weights that the object will experience will be more than 50 Newton. That means from here to here, it has increased in its weight. Now let me ask you a question. If the weight has increased, can you tell me how about the mass? Has the mass changed? Any idea? The answer is no change. Why? Because mass is independent of anything, any gravitational pull. The mass is always constant. The only thing that changes is the weight, because weight is dependent on the gravitational field. Alright? So what is gravitational field strength? So since we have learned about gravitational field strength is defined as the gravitational force acting per unit mass. Alright? So it tells us how strong the gravitational field is. On Earth, the gravitational field strength is approximately 10 Newton per kg. Note that Newton per kg has the same dimension as meter per second square. So that means that meter per second square is what you learned in last year. Meter per second square is acceleration, right? So that means acceleration, the unit of acceleration has the same unit as Newton per kg. So both have exactly the same unit. You can use this and this interchangeably. They are both the same. Alright, so that means you can say you can put as 10 Newton per kg in your examination, or you can put as 10 meter per second square, and you are both correct. Alright. So how do we prove that these two are the same? Okay, so first of all, let us recall what is Newton. Newton is force. Am I right to say that? So how do you find force? We find force using mass mass times acceleration, as you learned last year. F is equal to ma. So mass is in kg, and acceleration is in meter per second square. So that means that Newton is kg meter per second square, because force is Newton. So that means this Newton is equal to kg meter per second square, right? Understand? So that's how you get this relationship. So if you know this is kg meter per second square, alright? So Newton times per kg, that means you multiply a per kg here, will be kg meter per second square multiplied by per kg. So what happens to this kg? Using indices, these two kg will cancel off, leaving behind meter per second square, which is the same as the unit for acceleration. Alright? So that's why these two units are the same. Okay? So I'm going to move on. So let's summarize. What's the difference between mass and weight? Mass is the amount of matter in a body. Weight is the gravitational force. Mass is scalar quantity. Weight is a vector quantity. Mass unit is in SI. SI unit is in kg. Weight is in Newton. And mass is independent of the gravitational field strength, and it's always the same through in any parts of the universe, while weight is dependent on the gravitational field strength. Alright? Okay? So remember, mass is always the same. It will not change. Alright? So let's move on. So how are mass and weight related? The weight, or the amount of gravitational force acting on an object, is dependent on its mass. from chapter 3, which you have not studied yet, but you have studied in Sec 2. This chapter 3 actually refers to your chapter on dynamics, alright, or forces, just in case you do not know what does dynamics means. So we remember force equal to mass times acceleration. So do you remember that weight is also a form of force? So if weight is a form of force, then we can use this formula to find weight as well. So that means that this is your weight, alright, and then the acceleration, as we learned in the previous slide, is actually the gravitational field strength. Why? Do you remember that Newton per kg has the same unit as meter per second square? So actually gravitational field strength is your acceleration as well. So this will be your g. So this is your weight, this is your g. Mass will remain as the mass of the object. So what do you get in return? You get a subset of this original formula of mass equal to force equal to mass times acceleration, which is W equal to mg. This will be a subset. Alright, so you arrive at this formula. So this formula is originally derived from the original formula of F equal to ma. Alright, so they are very, very related. Okay, so let's move on. So what is the common instruments used to measure mass and weight? So the first one, for weight, the two common instrument is electronic balance. I know in lower sec, I think some of the slides actually say that electronic balance is for measuring mass, but I will explain to you why it is not. Both electronic balance and bathroom scale is actually used to measure weight, okay, and not mass. So why is it that in the real fact, when you actually stand on a bathroom scale, it gives you kg instead of Newton? As you know, kg is mass, so why do they not give you Newton, which is weight in this case? So the reason is because they are calibrated to give mass reading. That means that your bathroom scale or your electronic balance will give you kg, but actually it is measuring weight. Alright, that means they only convert the Newton to mass, but they are actually measuring using the idea of weight. Okay, so remember that. So if let's say you bring the bathroom scale or the electronic balance to another planet, it will not work. It will give you a false reading. Okay, so that means since it's calibrated to Earth's gravitational field strength, they cannot be used in a place of different gravitational field. So if you look at this, the weight of an elephant might be like 10 to the power 6 Newton. Here it becomes 1.6 times 10 to the power 4 Newton. So there's a great difference, but the mass of the elephant remains the same. Alright, so then what and how do we measure mass? We measure mass by using instruments that compare the masses. Alright, so you need to make sure that it does not depend on the gravitational field strength. So in order to not depend on the gravitational field strength, it has to be comparing the masses between two objects and then see whether they are the same. When they are the same, we can say that they are of the same mass. So a very common instrument that does this is called the beam balance. Alright, so the key idea is that it compares between the two masses to be able to judge what is the mass of the object. Alright, so since the object and the standard mass experience the same gravitational field strength on Earth and Moon, it will be the same. So that means that if you bring this to the Moon and you try to measure the mass of the object, it will give you exactly the same reading as it is on Earth. Alright, so this is to measure mass. Okay, so let's do a small quiz. So question number 1, at which point will the weight of the object be the smallest? And the second one is, at which point will the weights of the object be approximately the same? Okay, I would like you to spend about 30 seconds doing this. This is a very easy exercise, and you may pause the video now. Okay, so I expect that you have already gotten the answer. So for question 1, the answer is D. Alright, D is the smallest because it is the furthest away from Earth. So that's why it's the smallest. While the second answer is C and B because they are both at the same distance from the center of the Earth. They are at the same distance from the center of the Earth. So they will have the same gravitational field strength. They are at the same level from the center of the Earth. The other one is E and A. Alright, if you measure again, you realize that they are also at the same distance from the center of Earth. Okay, so B equal to C and then A is equal to E. So these are two sets. Alright, let's move on. Inertia. So what is inertia? So let's recall Newton's first law. Newton's first law states that an object will continue its state rest or uniform motion in a straight line unless a resultant force acts on it. Okay, so it is a law where there is no resultant force and what happens to the object. So basically when there is no resultant force, the object will be staying at rest or uniform motion in a straight line. Okay, so this is something you need to remember. Okay, so what is inertia in that case? So inertia is when an object is reluctant for the object to change its motion due to its mass. Okay, so this is the definition for inertia. In other words, a stationary object tends to stay at rest while a moving object tends to stay in motion. Okay, Newton's first law is also known as the law of inertia. So in other words, the law of inertia and the law of Newton's first law is actually the same thing, because Newton's first law states that an object will stay at rest or stay in a state of motion unless the resultant force acts on it. So in the same way, the law of inertia is also saying that the object wants to stay at rest or wants to stay in a state of motion. Okay, so let's move on. So let's say, so the other idea that you need to know about inertia is that the mass is the measure of the inertia. So the greater the mass of an object, the greater the inertia. So if you look at these two living organism, for the elephant, it has more mass. Am I right? So when it has more mass, and this guy has less mass, so we'll expect that the elephant has a higher inertia, correct? While the guy has a lower inertia. So the question is, should he run in a straight line or a zigzag manner to avoid the elephant? Obviously the answer is he has to run in a zigzag manner. Why? Because the elephant is so heavy with so much mass that he cannot change his direction as fast as the man. So if if the man is able to change his direction very fast, he can outrun the elephant by running in a zigzag manner. I believe that all the Sec 2 students, you have already, or last year, as in you in Sec 2, you have already actually learned about this idea and it was explained to you. Okay, I hope that you can write it in your own words. Okay, let's move on. So inertia is in everyday life. Let's say you are in a MRT train, and when the train stops suddenly, what happens is that you will observe that the passenger tend to move forward in the direction when the train is still moving. That when the train originally is moving. So it means that the passenger still want to move forward while the train has already stopped. Okay, this is due to inertia. It's the same way for buses. When the bus jams brake, when the car jams brake, you as a person in the car or the bus will tend to still move forward, alright, due to your tendency to continue in your state of motion. Okay, so can you predict what will happen if a stationary MRT train starts moving? Obviously, you will be jerked backwards, right? Same way when a car or a bus suddenly ram the acceleration and move very fast forward, you will be jerked backwards. The reason is because your body is still at rest and it tends to want to stay at rest, so it doesn't want to go in the direction of the bus, the MRT, or the car. All right, so this is something that you see every day. There are examples of inertia. Okay, so now we are at the last part of the lesson, which is on density. So what is the learning outcome for this part? Basically, we just have to recall and apply the formula of density, which is mass over volume, to solve problems. So let us look at the formula of density again. The density is defined as the mass per unit volume of a substance. So the symbol of density, which is rho, is given by mass over volume. So remember, mass must be in kilograms, while volume must be in meter cube. So that means that the SI unit for density will be kg per meter cube or kilogram per meter cube. Okay, so since we are at this part of the lesson, let me just bring your attention to the conversion between 1 meter cube and is how many cm cube. Alright, so a lot of students have this wrong idea that 1 meter cube is equal to 100 cm cube. That's not true. Now, to arrive at this answer, let us just look at what is 1 meter equal to. 1 meter is equal to 100 cm. So if 1 meter is equal to 100 cm, 1 meter cube will be equal to 1 meter times 1 meter times 1 meter. Am I right? So I'm moving from here to here, so I'm moving upwards. So if it's 1 meter times 1 meter times 1 meter, and you know that 1 meter here is equal to 100 cm, so now I sub this 1 into this 2. So I'm subbing this 1 meter with this 100 cm. So in other words, I get 1 meter cube is equal to 100 cm times 100 cm times 100 cm. Okay, so in other words, 1 meter cube is not equal to 100 cm cube, but is equal to 1000000. Okay, or equal to 1 million cm cube. There are 6 zeros behind. Okay, take note of the conversion. Alright, so I'm going to move on. So these are the densities of some of the common materials that you will find around you. So let's say you have 3 different material. One is turpentine, the other one is ice, and then the last one is water. Simply by comparing the density of these 3, you'll be able to tell which one is will sink and float. Okay, so what happened is that turpentine has a density that is the lowest, while ice is in the middle, and then lastly water is the highest. So what happened is that the lowest density will float, while the highest density will sink. Alright, so in other words, when ice is in water, ice will sink while water will ice will float while water will sink. If ice is with turpentine, ice will sink while turpentine will be in above the ice. Alright, okay, so the highest will sink and the lowest will float. So let's move on. So what happens when you have a steel ship in water? We know that steel is a very dense material, but why is it that a steel ship can float in water? So we need to know that even though steel has a higher density than water, okay, steel can the ship can still float. The reason is because we need to consider that the ship is not made of one material, but it is made of more than one material. And because of that, we need to calculate the average density of all the materials that are added together. Alright, so a simple idea is that you need to imagine that the metal part is actually a very small part of the ship construction. Now let's say this is the metal part. The metal part is actually only the hull. Alright, so this is your steel. Okay, so what happened is that within the ship, right, Okay, let's say this is a ship. Within the ship, there is a lot of empty space inside here, which is filled with air. Alright, so even though the ship, the density is high, okay, the air density is low. Okay, if you consider the two materials together and you take the average density, you will realize that the average density of these two materials together may be lower than that of the density of water. So because of that, there is a tendency that the ship will be able to float because the average density is lower than that of the water. Okay, so now we go to the work examples. What I need you to do now is to pause the video and try the questions first before I reveal the answers to you. Okay, you may pause the video now. Okay, I hope that you have already solved this question, so I'm going to show you the answer now. So if you want to find the volume of the first of all, if you want to find the mass of the wood, first of all you calculate the volume of the wood, which is length times breadth times height, and then after that the mass of the wood will be given by density multiplied by volume, because density is equal to mass over volume. So mass is equal to density times volume. Alright, so nothing special about this. So when you multiply together, you get 0.01 kg. Okay, so I hope that everyone can get this correct. This is a very simple exercise. Let's move on to the next exercise. Okay, so pause the video and then try the question now. Okay, I hope that you have already found the answer. So if you want to find the density of the rock, very simply you must first find the volume of the rock, which is the final volume of the water subtracted by the original volume of the water, V2 minus V1, which gives you 2.4 cm3. So the density will be given by mass over volume, which is equal to 50.2 over 2.4, which gives you 20.9. So this question is again quite a straightforward question. Okay, let's move to the last question. So what happens if you want to find the length of a cylinder given the weight as well as the density? So first of all, you must convert the weight to the mass. So you can pause the video at this point in time first and try the question first. Okay, I hope you have solved it. So first of all, you must convert the weights to mass using W equal to mg. So this is given, this is from the formula W equal to mg. So m is equal to W over g. That's why you get W divided by g. So you get 50 Newton divided by 10, which gives you 5 kg. So after that, you can find the volume of the cylinder using the formula of density equal to mass over volume. So volume will be equal to mass over density. Alright, so you get m over density. So you get 5 divided by 7800, which gives you 6.4 times 10 to the power minus 4. So since volume is given by area times length, we can express as pi r squared length, because it is the volume of a cylinder. The area, the cross-sectional area is pi r squared. So that means that this whole volume will be equal to 6.4 times 10 to the power minus 4 meter cube. So if you equip the two together, you get 6.4 times 10 to the power minus 4 meter cube divided by pi r squared, and you can find the length. So one of the key things you need to be careful about is that this radius, which is here, you must convert to meters. Okay, a lot of students will commit the error of not converting to meters. So that's why they got the error. So I hope that you did not commit this error. Alright, so the answer will be 2.04 meters. Okay, so this is a summary of the whole chapter. Basically, do take note that this last page is always a very advantage concept map that you can use to help you to recap on the important parts of the chapter. Okay, use this to help you to create your own notes. All right, this is by no means exhaustive. There are areas that you can add to it. All right, so use this as a starting point to create your notes, and you can actually produce pretty good notes from here. Okay, so that's all for this chapter. Please do the worksheet and hand up at the deadline that was given to you. Thank you very much and have a nice day.